Hello everyone, my name is Samer Al-Batal, and in this presentation I'll be going over the four different focus sequences within the structural engineering program at UCSD. For each focus sequence, I'll briefly explain what the field involves, why it's important, and some of the types of work engineers in that field typically do. Firstly, we have the civil structures sequence. This sequence deals with the design and maintenance of infrastructure, including bridges, buildings, highways, and dams. Civil engineers undertake the responsibility for keeping those structures safe during routine use, harsh weather conditions, and earthquakes. Infrastructure is constantly aging and deteriorating. Therefore, there's a huge need for civil engineering. For instance, roads crack, bridges corrode, and buildings wear out with time. So, without engineers to assess and repair such systems, infrastructure would become unsafe. Typical problems civil engineers solve might include things like calculating structural loads and material selection like concrete or steel. And some potential careers within this domain can be structural engineer, construction engineer, civil engineer, or city engineer. Moving on, I will be discussing the field of the geotechnical focus sequence. Geotechnical engineering involves the analysis of soil, rock, and foundation conditions for any structure well before the construction actually starts. This field becomes important because if the ground is unstable, weak, or has some surface unevenness, even the most powerful structure may fail. Engineers evaluate soil composition, groundwater behavior, and land movement to prevent settlement, sinkholes, or slope failure. Careers in geotechnical engineering include foundation design engineers, field engineers, and geotechnical consultant who assist developers to minimize um, the risk of prior to minimize the risk prior to the onset of construction. Uh, Following that, I will be discussing the aerospace focus sequence. Aerospace engineering designs structures used in aircrafts, rockets, and spacecraft. Whereas civil engineering can needs heavy materials, aerospace structures must be extremely lightweight yet strong and durable. This field exists because flight subjects structures to a set of extreme stresses such as pressure changes and temperature variation. So materials are carefully analyzed to make sure they can survive high speeds and extreme environments. Aerospace engineers test material performance, perform stress analysis, and work on new technologies designed for efficiency and safety. This includes parts such as wings, fuselages, or rocket frames. And finally, I'll discuss SHM, which is structural health monitoring. It deals with the tracking of structures' conditions over a period of time, applying sensors and data systems. Rather than waiting for visible cracks or damages to appear, this data is collected remotely to pinpoint potential problems. This field is important because it enables the engineers to identify weaknesses before they reach catastrophic failures. Sensors can continuously measure motion, vibration, and material degradation. Using computer models, engineers interpret real-time data to understand patterns indicative of fatigue or stress. It becomes increasingly important as structures get older and budgets preclude full replacement. And the focus sequence that is the most interesting to me is definitely the civil structures focus sequence because, as you can see, this is a building my dad and my oldest brother built back home in Lebanon. And I really like this domain and I want to continue this working in this field like my family does. Also, this field of civil engineering allows me to apply the theory of structure to real problems and contribute to the safety of people, whether in roads, bridges, or buildings. I also appreciate the balance between technical work and practical impact. That's why I aim to pursue the civil focus as my career path. And thank you very much.